We are going to analyze box and whisker plots. So in the last lesson you learned how to construct them, and in this lesson we're going to actually analyze them. So do not do this lesson unless you've done the previous lesson, whether it's on YouTube or in class, where you learn how to construct box and whisker plots, because this lesson won't make sense. Alright, so let's go ahead and get started. We're actually going to jump right into examples. There's a mini lesson in the middle of this lesson that we'll get to later. So example number 1, we have a box and whisker plot right here, and the question is the number corresponding to A, so A right here on the box and whisker plot, is which of the following? Is it the median of the data, the least data value, the first quartile, or the third quartile? So think about which one it is. So the answer is going to be B, the least data value. And the reason why is because A is the lower extreme, which is the smallest number. C would be the median. The first quartile would be B right here. So this would be the lower quartile. And then the upper quartile would be D, which is the third quartile right here. And then E, even though it's not an answer choice, that is the upper extreme, which is the largest number. Okay? Let's look at number 2. To find the range, so just the range, not the interquartile range, just the range of the data, which of the following should you compute? The number for D minus the number for C, the number for E minus the number for A, the number for D minus the number for B, or the number for C minus the number for B. So first of all, think about how do you calculate the range. Well, range is the big number minus the little number. So big minus little. So you're going to take the largest number minus the smallest number. Well, where's your largest number? So your largest number is right here. And where's your smallest number? Right here. So you're going to do E minus A. And that's going to leave you with answer choice B. All right, number 3. The first quartile is closest to which number? So again, you're going to have to first find where is the first quartile. So let's label. So this is the lower extreme. That's the smallest number. This is the lower quartile. This is the median. This is the upper quartile. And this is the upper extreme. So where's the first quartile? That's this right here. So which number is it closest to? And that would be C, 400. All right, example 4. The interquartile range, so now we're doing interquartile range, can be found by calculating which of the following? The number for D minus the number for A, the mean of the numbers for B and D, the mean of the numbers for A and E, or the number for D minus the number for B. So here's the thing, with box and whisker plots, we really don't use the mean at all, okay? We may have to use the mean when we get down to 2 numbers and we're trying to find the median, but other than that, we really don't use the mean. We use the median. It's all about the median. And so when you see answer choices that talk about a mean, they're usually incorrect, okay? But let's go ahead and solve the problem anyway. So what is interquartile range? So the interquartile range is the upper quartile minus the lower quartile. And so where is the upper quartile? It's right here. And where's the lower quartile? Right here. So we need the number for D minus the number for B. And that's going to give us answer choice D. All right, example 5. What was the median daily high temperature? So first off, where can you find the median on this box and whisker plot? Well, the median is this center line going down the middle of the box. Now, what number does this right here correspond to? Well, if this is 70 and this is 80, how are they counting in between? By ones, by twos, by threes, by 0.5s? How do we know? So let's count by ones. 71, 72, 73, 74, 80. That doesn't make sense. Let's try by twos. 70, 72, 74, 76, 78, 80. That makes sense. So they were counting by twos. So this right here would be 72 degrees. All right, example 6. What is the interquartile range? So this word again, interquartile range, for this set of data. So again, what is the interquartile range? That is the upper quartile minus the lower quartile. So our upper quartile is here, and our lower quartile is here. So we're going to do 45 minus 30, which equals 15. And that's going to be answer choice A. All right, now we're going to take some notes here. So when we talk about box and whisker plots, we can also use some percentages. There are 5 percentage points on the box and whisker plot. And I have a picture here that you also need to fill in. Okay, so there are 5 percentage points on a box and whisker plot. So let's go ahead and talk about them. So first look at this picture. So here's your number line. Okay, here's your box and whisker plot. Here's your lower extreme, here's your lower quartile, here's your median, here's your upper quartile, here's your upper extreme. Okay, these are all things that you're already familiar with. Now, let's add in some percentages. And don't get freaked out because they're actually very, very easy. Okay, so every time we go from one section of the box and whisker plot to another, no matter how big or how small that section is, it counts as 25% of the box and whisker plot. So from the lower extreme all the way to the lower quartile is 25%. From the lower quartile all the way to the median is another 25%. From the median to the upper quartile is another 25%. From the upper quartile to the upper extreme is another 25%. Now, look carefully. Do you see how large this space is right here compared to this tiny space right here? That's okay. It still represents 25%, no matter how big or how small it is. Okay? They are each 25%. Now, 25 plus 25 plus 25 plus 25 is going to give you a total of 100%. So, when you start out at the lower extreme, you're at 0%. When you get to the lower quartile, you're now at 25%. When you get to the median, you're now at 50% because that's 25 and 25 is 50. When you get to the upper quartile, you're now at 75% because that's 25, 25, and 25 is 75. And then when you get to the upper extreme, you're at 100% because that's 25, 25, 25, and 25. So let's go ahead and practice those percents now, okay? So here's a box and whisker plot. It's talking about the height of 7th grade students in inches, okay? What percent of the heights of the students is between 60 and 65 inches? First of all, before we even look at the box and whisker plot, I want to point something out to you with these answer choices. We just talked about the acceptable answers in terms of percentages. Your options were 0%, 25%, 50%, 75%, and 100%. Those were your options. If anything else is an answer choice, it's wrong. So which one of these is automatically wrong? C. I never talked about 62.5%. So you can automatically eliminate that. Okay? So now let's go back to the question. What percentage of the heights of the students is between 60 and 65%? So let's find 60 and 65%. Okay? Now, from here to here is 25%. From here to here is 25%. From here to here is 25%. And from here to here is 25%. So the question is asking you, how much is it from 60 to 65 total? Well, the answer is going to be B, 50%. Because it's this 25 and this 25. And 25 plus 25 is 50. Okay, let's do number 8. According to this box and whisker plot, what percent of students study less than 16 hours per week? Okay, first of all, look at your answer choices. Which ones are not acceptable? Remember, our acceptable answers are 0%, 25%, 50%, 75%, and 100%. We can get rid of D and C automatically when we're talking about a box and whisker plot. Okay? So, according to this box and whisker plot, what percent of students study less than 16 hours a week? So find 16, and it wants to know how many study less than 16 hours a week. So less than means it's going to go less than, okay, towards the left. So from here to here is 25%. And since I only want less than, that's all I need. I don't even need to fill out the rest. So the answer is going to be B, 25%. Okay, number 9. Which box and whisker plot represents a situation where 75% of the data is 200 or less? So we're going to go through each one and find 200 first. So here's 200. Now, is 200 75% of the data? Well, from the beginning to 200, that's 25%. So that's wrong. Okay, let's move on to B. Here's 200, but 200 in this box plot does not sit on the median or the lower extreme or the upper extreme, so we can't tell. So that's wrong. Let's go to C. Okay, so 200 sits on the median. So from here to here is 25%, and then from here to here is 25%, and here's 200, so 25 plus 25 is 50%. Is that what we want though? No, we want 75%, so that's wrong. So now let's look at D. Here's 200 on D. So from the lower extreme to the first quartile is 25%. From the first quartile to the median is another 25%. And then from the median to the third quartile is another 25%, and that's where the number 200 was. 25 plus 25 plus 25 is 75%, and that's what we want. So D is the correct answer for that one. All right, number 10 is the last one, and this one is the trickiest problem. Okay, we got to read it very carefully. Which statement is true about the data set? So first of all, before we even read the answer choices, let's take a look at the box and whisker plot. These are high temperatures for 50 cities. Okay, our lowest value is 40. Our highest value is 100. our middle number, our median, is between 70 and 80, or sorry, between 70 and 85. Nope, what's our median? I'm sorry, 75. Come on, Ms. Oates, get it together. Okay, so let's take a look now at the answers, the answer choices. So, which statement is true? The lowest high temperature is 70 degrees. Half of the cities had a high temperature of 75 degrees or higher. The mean of the high temperatures is approximately 75 degrees. More cities had high temperatures between 40 degrees and 70 degrees than 84 degrees and 100 degrees. Okay, so let's tackle these one by one. The lowest high temperature is 70 degrees. Well, what's the lowest temperature? 40. Is that 70? No, that's not true. Half. What does half mean? Well, it means 1/2, but what does it mean in terms of percentages? 50%. 50% of the cities had a high temperature of 75 degrees or higher. So 75 is right here. So is it true that 50% had a high temperature of 75 degrees or higher? Well, let's see. So from here to here is 25%. From here to here is 25%. 25 plus 25 equals 50%. That is true, but let's make sure. The mean, remember what I told you about that word mean. Box plots focus on the word median more so. The mean of the high temperatures is approximately 75 degrees. That's incorrect. The median is 75 degrees, so that's incorrect. More cities had high temperatures between 40 degrees and 70 degrees than between 84 degrees and 100 degrees. That's also incorrect. We don't know that. Just because this line is longer does not mean that you had more data values here. It just means that the data could have been more spread out, okay? So, B is our correct answer for this last problem. All right, that is the end of this lesson. We will do some more analysis in class. Let me know if you have any questions.